So today we're looking at 2.3, talking about problem solving, just like we did the other day. This time we're going to use inequalities. So in in all of the problems, it's going to be using these keywords and phrases to tell you which inequality symbol to use. Okay, so like, for instance, if you see x is at most a certain number, then x is going to be less than or equal to that certain number. Okay, so all of these are just like basically a hint to you on how to set it up. All right, so we're going to do two examples together, and then you can try some on your own. If you need help setting them up, I'll just walk around and help whoever needs help setting them up, and give you some time to work on them. All right, so example number 1, I'm going to read it to you, and just like when you are doing your assignment, I'm not going to make you write down the whole problem. If you want to write down the whole problem, go for it. Write the whole thing down. Some people it helps them like organize their thoughts. I like to just write down a few key words. Okay, so here's what the problem says. A bus is to be chartered for the senior class trip. The basic fare is $9.50 per passenger. If more than 20 people go, everyone's fare is reduced by 30 cents for each passenger over the number 20. At least how many people must go to make the fare less than the $7.50 per passenger? So basically, if I'm going to organize the trip, I'm going to tell all of you, prepare to pay $9.50. But if you can get all of your friends to go, we can pay less, right? Because the more people we can squeeze on that bus, the cheaper it's going to be. We can spread the cost out better, okay? So the key word is less than. You want to be less than $7.50, okay? But we start out at $9.50, okay? So you don't mind paying $9.50, but it would be nice if you paid less, right? So you start out at $9.50. We're going to subtract 30 cents for every person that's over or more than 20. So the way we write that is the number of people will be n minus 20. Okay. This will be how many people over 20. So like if there were 32 people going, how many people over 20 would that be? 12. You'd go 32 minus 20. That would get you 12. So there'd be 12 people over 20, and you'd multiply it by the 30 cents, subtract that from $9.50. We want that to be less than the $7.50. So off of our little little chart, actually that one's not even listed there, we're just going to use the less than symbol, $7.50. Okay. Then from here it's all calculator work and a bunch of algebra, right? Okay, we've got $9.50. We've got this negative 30 cents out front. I'm going to distribute it here and here. So from $9.50 minus the 0.30 times n, and then negative 30 cents times negative 20. If you do that on the calculator, I got 6. All right. Now algebraically, I need to combine like terms and solve for my variable, right? So I'm going to combine the $9.50 and the $6 to get $15.50. Bring down that negative 30 cents. And then getting the variable by itself by subtracting $15.50 from both sides. That leaves us with negative 30 cents less than, and you can do this on your calculator, $7.50 minus $15.50. I got negative 8. Since we have negatives on both sides, we're going to end up with a positive, so that's good. But when we divide by negative 0.30, we have to reverse the inequality, right? So these cancel, and we have n flip this around to greater than, and then if you type this in your calculator, you're going to get something like 26 point, and then in your calculator it's going to say 6666666 all the way across your calculator screen, right? That's like 6 with a bar. Okay, if you think back to the question, we're talking about people, right? Can you have 0.6 of a person?
Yes.
You would be the class to say that. No, you cannot have 0.6 of a person.
Okay.
Jump off an arm. Okay. So if we're talking about people, we need at least how many people? 27. So we need to say at least 27 people need to go if we want to pay only $7.50. No, you mean graph it? No. All right, example number 2 says find all 4 sets of consecutive integers whose sum is between 10 and 20. So the keywords are is between 10 and 20. And so if you look at your little phrases, between 10 and 20, you always want to write the smaller number on the left and the larger number on the right. Doesn't say inclusive. So we want in here the sum, how did it word it? Find all the sets of 4 consecutive integers whose sum is in there. So we need our first number, our second number, our third number, and our fourth number. Okay? Consecutive just means one right after another, right?
Yes.
So if we started with 1, we'd go 1, 2, 3, 4, 5, right? Okay? But we're not starting with numbers, we're starting with a variable. We're going to use x, but you can use whatever variable you like. So what would be the second number?
X plus 1.
And then the next one would be x plus 2 and x plus 3. Okay? We need their sum, S-U-M. So we should do what with them? Add them all up. So how many x's do we have? 4 x's. And how many numbers? 6. So 4x plus 6. So 4x plus 6 goes in here because that's the sum of 4 consecutive integers. All right. So now we've got 3 parts to our inequality. We want to solve based on what's happening here in the middle, right? To get that x by itself. So subtract 6 from all 3 parts. On the left, we get 4. In the middle, we get 4x. On the right, we get 20 minus 6, which is 14. Okay? The x is being multiplied by 4, so divide by 4. So 4 divided by 4 is just 1. That's nice. These cancel. Down to x. That's nice. Over here, 14 divided by 4. Is that going to get us a whole number? No, it's not going to get us a whole number or an integer. So 4 goes into 14 like 3.5 times. Okay. So we need the integers that are going to fit in between 1 and 3.5. There are 2 will go in there. What other number? 3. Okay? So we need the 4 consecutive integers starting with 2. So that would be 2, 3, 4, and 5. And then we need the 4 consecutive integers starting with 3. So that would be 3, 4, 5, and 6.